Hello everyone. Before starting the lesson, try this warm-up. Factor the expressions fully. So pause the video and try factoring these expressions as much as you can, and then check back in to see how you do. The first one is a simple trinomial, so I need to find two numbers that multiply to -8 and add to -2. It's +2 and -4. So here's the factored form. The next one, I don't have any common factors, so this is a complex trinomial. 12 times -2 is -24. So I need two numbers that multiply to -24 and add to -5. Well, that's +3 and -8. I decompose the middle term. Then I factor by grouping. 4x plus 1 is now a common factor, and I'm left with 3x minus 2. If you had trouble with the factoring, you can let me know. Otherwise, let's move on. This lesson is about simplifying rational functions. I want to stress that the root of the word rational is ratio. A ratio can be written as a fraction. So these are functions that include fractions, and it's going to get pretty intense, so watch out. We're going to define rational functions and see what they are. We're going to simplify rational expressions, and we're going to identify restrictions. And you might recognize the word restrictions from when we talked about domain and range. A rational function is the ratio of two polynomials. So for example, I can write it like this. F of x is equal to r of x divided by s of x. It's the ratio between these two functions. Because I can write it as a fraction, this is a rational function. Restrictions are the values of the variable in a rational function that cause the function to be undefined. Or I can say the numbers that are not in the domain of the function. Here's an example. F of x is equal to x squared minus 2x plus 3 over 4x minus 1. Now, a restriction would be that x cannot equal 1 over 4. The reason for that is that in a fraction, the denominator cannot be 0 because you cannot divide by 0. So if I know that 4x minus 1 cannot equal 0, I can solve this inequality. 4x minus 1 can't equal 0, which means 4x can't equal 1, which means x can't equal 1/4. So this is called a restriction because I'm restricting the values of x. They cannot equal 1/4 in order for this function to work. Now this is the first of many examples in this lesson, and the common theme is that we must simplify the rational expression first before we can state any restrictions. And in order to simplify, we have to factor. Factor the numerator and factor the denominator, and that helps us to see restrictions easier. Let me explain. When I look at the numerator, I notice that it is a simple trinomial, and I can factor it. I need two numbers that multiply to 15 and add to 8, 3 and 5. So this is the factored form of the numerator. The denominator is a difference of squares. So when I factor it, I get x plus 3 times x minus 3. Now remember, the denominator of a fraction can't be 0. So that means x plus 3 times x minus 3 can't equal 0. So I'm just going to do my thinking off to the side here so you can see what I'm talking about. The denominator can't equal 0. Now, look at what I'm doing. It's these brackets multiplied by these brackets. If I'm multiplying two numbers together and the answer is 0, that means one of the numbers has to be 0. This is called the zero product property. So if x plus 3 can't equal 0, that means x can't be -3. And if x minus 3 can't equal 0, that means x can't equal 3. So I've figured out some restrictions already as I'm working through this problem. Always keep an eye on the denominator. Because the denominator can't equal 0, you can keep track of what your restrictions are going to be, and you can bring them back at the end of your solution. But let's just keep going because we haven't really simplified the expression yet fully. Notice this. The numerator and the denominator both have x plus 3 as a factor, which means they can cancel each other out. And then I'm simplifying my expression to just x plus 5 over x minus 3. This is now simplified. And to finish it off, I have to state my restrictions. So yes, the function is x plus 5 divided by x minus 3, but I have to say x cannot equal positive 3 or negative 3. And the reason for that is what I already discussed over here. So when it says simplify the rational expression, factor, and if there's any common factors that cancel each other out, you cancel them out, and whatever you're left with is the simplified expression. Keep track of your restrictions before you start canceling out the factors, because you'll notice if I try to just find the restrictions at the end, I wouldn't have noticed that x can't be negative 3. I would have only said that x can't be 3. So just make sure you keep track of your restrictions as you go and not just wait till the end. Now for this next example, it's the same question being asked, just starting with a different expression. Simplify the rational expression, state any restrictions. Remember the method. We factor the numerator, we factor the denominator, we keep track of restrictions, and we cancel out factors that are common to the numerator and the denominator. So why don't you try this on your own, pause the video, and then see how you do. The numerator has a common factor of p, and we're left with p minus 5 as the other factor. The denominator is a simple trinomial, and when I factor it, I get p plus 2 times p minus 5. Off to the side, I think about that zero product property. P plus 2 can't be 0, which means p can't be negative 2, and p minus 5 can't be 0, which means p can't be 5. I notice that p minus 5 divided by p minus 5, they cancel out. I'm left with p over p plus 2. And I state my restrictions. P cannot equal negative 2 or 5. I'm writing it in set notation here, just because p can't be the set of these two numbers. It's kind of like how we were writing domain and range before. Here's another one. So pause the video and try this one. Same method, just a different question. The numerator is a simple trinomial. This is how it factors. The denominator, I can do common factoring. 3x is the common factor. I notice that x minus 6 can be canceled out, so I'm left with x minus 2 over 3x. My restrictions came from this denominator. X can't be 0 and x can't be 6. And that's how I write it at the end. Here's another one. Why don't you try this one? Pause the video and see how you do. In the numerator, the common factor is 6. In the denominator, the common factor is negative 7. I'm left with simple trinomials in each case, which factor like these. Here, I thought to the side here what my restrictions would be. M can't be 1 and M can't be 2. M minus 2 cancels out, so I'm left with this. Now some people might think you should cancel out M plus 1 and M minus 1, but they are not the same factor. They're different. One's plus, one's minus, so you can't cancel those ones out. Now the wording of this question is a little different. It says, determine the domain of the function. Well, in order to determine the domain of the function, we have to figure out what the restrictions on x are. And how do we do that? Well, the same as what we were doing before. We're going to follow the same process. We'll factor the numerator, factor the denominator, figure out what the restrictions are, and then we can simplify and then write our domain. So pause the video and try to simplify this function and figure out what the restrictions are. This one was a little trickier just because there was more factoring to do, but follow the same process. If we factor the numerator, look for common factors first. 3x squared is the greatest common factor, and we're left with x minus 1. In the denominator, 4x is the greatest common factor, and we're left with 2x squared minus 3x plus 1. Now, this is a complex trinomial, so I'm going to factor it further. I just did that off to the side here. I followed the method of decomposition, factor by grouping, and then you find the factored form. So that brings me to my next line over here. The denominator is now 4x times 2x minus 1 times x minus 1. Now that the denominator is fully factored, I'm going to look for restrictions. X cannot equal 0. 2x minus 1 cannot equal 0, in which case x cannot equal positive 1 over 2. And also x minus 1 can't equal 0, which means x can't equal 1. So I figured out what the restrictions are on x, and now I simplify. X minus 1 is canceled out. We have x squared in the numerator, divide by x in the denominator. So those x's cancel out. I still have an x on the numerator that remains there, but this one is gone. So this is the simplified form of the function. F of x equals 3x over 4 times 2x minus 1. And I already figured out my restrictions earlier, so now when I write the domain, because that's what I was asked to find, the domain is, well, x can be any number. X is an element of the real numbers. However, x cannot equal 0, 1 over 2, or 1. So that's how I would write the domain for this function. Now this next and final example combines the previous lesson with this lesson. So in the previous lesson, we learned how to determine if two functions are equivalent. The way we did that was we subtracted one from the other. And if the answer was 0, then we knew that they were equivalent functions. Now we're going to do the same thing here, except it's a little trickier because, well, these are rational functions. So do the same as we've been doing this entire lesson. Factor, simplify, and then see if they're the same. So this one's a little trickier. You can try this one if you want to. Otherwise, you can just skip ahead to my explanation. Well, here I've factored f of x, simple trinomial, factors like this, and the denominator also is a simple trinomial, factors like this. These two cancel out, and we're left with this. Now watch this. X plus 2 over x plus 4. Well, that's what g of x is. So we would think, well, look, they're the same. F of x is x plus 2 over x plus 4. G of x is x plus 2 over x plus 4. They're equivalent functions. However, look at the restrictions. X plus 4 can't equal 0, which means x can't equal negative 4 in g of x. But when I kept track of my restrictions in f of x, well, x can't be negative 4, but also x can't be 3. So there's one more restriction on x in this function than there was in the other one. So because of this, even though the simplified expressions look the same, we have different restrictions. So we cannot say that the functions are equal. So if you graphed these two functions, they would look extremely similar, except f of x has one more hole in it than g of x does. And because of that, they're not exactly the same. They are not equivalent because they have different restrictions. So I used this example just to highlight that you have to pay attention to restrictions because functions might not be the same if they have different restrictions. I want to close this lesson with a challenge. This is for those who are feeling up to it. It's more of an extension problem that you can try. The perimeter of this isosceles triangle is 30x plus 10. That's the perimeter. Determine the ratio of the base to the perimeter. This is the base. The perimeter is the total distance around the outside. State the restrictions on x. Why is this restriction necessary? So this relates back to context. See what you can come up with if you're up for the challenge. So pause the video and try it. I knew that the base plus 2 of these other sides equaled the perimeter. That's what this is. So if I want to find the length of the base, it's the perimeter minus the 2 other sides. That's where this came from. I expand and I simplify, and this is the length of the base. So when it says determine the ratio of the base to the perimeter, I'm finding a fraction. A ratio can be written as a fraction. So base to perimeter is 12x plus 4 to the perimeter, which was 30x plus 10. Now I'm going to simplify this by factoring and then canceling out the factors. So the ratio is 4 to 10. After I had the denominator fully factored, I found the restriction. X can't be negative 1/3. Now, why is this restriction necessary? Because if I look at these lengths and I were to substitute negative 1/3 into here, 9 times negative 1/3 would be negative 3 plus 3, that would be 0. I would have side lengths of 0 in this triangle. Well, that doesn't make sense. I can't do that, so that's why this restriction is important. And now it's time to practice. So remember the key steps. If you have a rational function, you need to factor the numerator, factor the denominator, keep track of restrictions, and then simplify by canceling out factors that you see in both the numerator and denominator. If you have trouble with this, let me know and I'll do my best to help.